You know that hum song, Why I Like the Robins?
I do.
I'm going to tell you why I like Scott Robbins.
If anyone else out there knows the song, please let us know, because there's not enough Hum fans in the world.
So, Scott Robbins, who is an attendee of Cleveland Cocoaheads with us, put together this really cool playground about the composite pattern. The link will be below. Probably best to check that out before you hear us talk about it. First thing that I'll talk about is
What kind of horrible things are you going to do to Scott's code?
probably all of them. So first, the first thing that I'm going to convert, after I saw Scott's presentation at Cocoaheads, or during the end of it, I was thinking it seems unnecessary to have a bunch of objects which implement protocols, when what I actually saw him doing was using functions that were composites of other functions near the end of the presentation. So we'll get to that, or I'll get to that later on. But the first thing that I'll go over is how I converted this empty string validator into what I will show you. Validators implement this function, single function, where a string is validated, it returns a validator result. That's going to be common to many things. I tried to take that commonality and turn it into an enumeration. So that's what that would look like if we were actually able to back an enumeration with a function. So I can't really assign the raw value of the enum. Hey, why do we say enum instead of enum?
Because it's an enumeration and not an electronic number.
I think that it actually used to be an enum, because you can always assume that the things that were backed by numbers. But now in Swift, you'll see a lot of things that are backed by strings, by floating point value. Well, okay, those are numbers. But okay, as soon as you say I'm sorry. As soon as you back an enumeration with something that is not a number, I can't see it as an enum, because it's not just that it's an abbreviation. It's like there's a number in it. It's really not. So we say enum. So first, I say I'm going to have a bunch of things which I will call the cases of validate. I will call them validates. Each function will be called validate. The name of it will be validate. It will validate something. But what it will validate will be different. Another thing that we're going to need when we validate is an error that can be thrown. So we will extend validate with an error, which right now all we know that we're going to need is the empty case.
Okay, I'm with you so far.
I'm going to make a generic test function that I'll use for testing various things in this presentation. It will take one of these validates, right? And that signature. There's the signature. So it will take one of these validates. It will take the string that it's going to be validating, which doesn't need a name. We just need to know that it is a string. And then we're going to say what kind of error is expected. Then we'll assert that an error is thrown.
I have never seen the assert throws error before. I've only really used, like assert equals or similar, so.
The test will only pass when we actually are executing this closure, which happens when an error is thrown. And here we have that error. So we'll have one more case later on, but for right now, the only thing that this might be is going to be a validate error, and then we'll just make sure that that error is equal to the one that we expected. The default will be that we fail. This will never actually happen, but right now, errors in Swift are not exhaustive. So it can't know yet that this is the only possible thing that could be thrown, because you can't say what kind of error a function throws yet. For implementing, testing that a string is not empty, we'll use that test function. So we'll say validate not empty. Validate that this empty string is not empty. Of course it is. So we expect to see the .empty error. Here is our first instance of a validate.
Okay. So I like your use of guard here. And I know to some of our local Cocoaheads this seemed a bit novel, but I grew up reading your guard statements in the snow uphill both ways, so... You're not using guard let, it's just a guard else.
Yeah. So make sure that the string is not empty. Otherwise, we'll throw in the error that goes along with the string being empty when you try to validate it. So with the validate not empty function, we can run the test, and it now passes because we do get the error back that we expected to get. The next validator that we'll have a look at is the email format validator. I love this constant name. So his function is kind of hilarious. We'll be basically using it directly. But I'm considering this to be another case of validate. Let's start with the tests for validating email address format. First, we're going to say what kind of error we'll expect. So this won't just be a validate error. This is going to be a validate email address error. And because we're only going to be testing things having to do with emails, here we'll do a type alias. Our local error type will be email address errors. And our function will be test format. So again, we'll use that test function where the validate we're using is for email address format. We'll pass in an invalid email address, and we expect to get an format error. So we'll extend validate with an enumeration that acts both as a namespace and as a place to put validate email address cases. Now, they're not really cases. They're just going to be static functions, but they will have the same kind of look. So when here we had validate dot not empty, here we'll have validate dot email address dot format, because we're validating the format of the email address, not of any string.
Okay, so when you're using it, it will look like what you would have wanted, but...
Right, looks just like that.
Okay.
So we will throw error.format. Of course, within validate email address, this is that sort of error. It won't compile yet because we have not defined error.format. What I'd like to see is this, except for the fact that I forgot to implement error type here, but it wouldn't compile anyway. I'm not going to be able to do that because I'm going to need to throw multiple errors, and they're all going to need to be the same type. I'll show you that shortly. The way I'll get around what I want to do, which I just showed you, is to define a validate error for email address. So I'm imagining that this would be a dot. I often emulate the dot with an underscore. And then I can still have it look like I want, but it needs to effectively alias a validate error as opposed to a validate email address error. So there is no real format error, but it looks exactly the same as it would when we can do what I want to do in the future. So now let's actually start using the real composite pattern. If we go to Validator Configurator, let's look at the email section. You'll see that Scott was using the empty string validator along with the email format validator and making a composite validator out of those, which takes however many validators you want to pass in, and it will make sure that every validator finds the string to be valid. So the first thing that I'm seeing there is that we'll need to send multiple errors. Scott didn't actually implement that. It's not a thing that he got to in his presentation. So I had to figure out how I might go about doing that, and I tried to look up to see if anybody had done that on Stack Overflow or anywhere else, and I didn't find it. So I'll show you what I came up with. Maybe you can do better.
So you have a struct that's an error type here.
Right. So normally what you'll see conforming to error type in Swift is an enum.
Enum.
But in the enum, you'll see cases that are all errors. But you can actually conform to error type with any type. And the reason that I'm using a struct is so that I can store a property. You can't do that with an enumeration.
I see.
So what I want to store is a set of errors. Now, what I'd really like to have is just the ability to throw a set itself as errors. So now I have to say errors.set. I originally had error.errors. There's not a good way to name this. So we'll initialize the errors struct with a sequence type whose elements are validate errors. And then we'll make a set out of that, whether it's a set or not to begin with. Because there's no point in storing, I don't think there's any point in storing the same error multiple times, and I don't think the order is important. So I think a set is the right match for this constant. Now that we can composite errors, we also need to be able to composite the functions that throw the errors.
That is another fake initializer like we saw in the last screencast.
It's a fake initializer because what I really want to do is make a new case of an enumeration.
Okay.
And there's no construct in Swift that allows you to, in code, make a case. The cases right now just have to be constants at compile time. So I am going to be creating what I'm considering to be the raw value of the validate enum. I have seen nothing about this kind of thing coming into Swift's existence, but it would look just like this aside from the underscore init. If it were ever possible, I'd be making a new validate case, or very similar to that.
So let me see if I understand what you're doing here. You're collecting all of the errors that would be thrown with a flat map, and then you're throwing them all together.
Right. So this is a curried function. We're going to return a function that's going to take a string. It's going to be a validate. So we'll actually make an array of errors because that's what flat map returns. So we'll take all of our validates, and for each one, we'll return a set of errors. If we can actually validate the string, then we'll return an empty set. If they were all empty, then flat map would just take all of them and squish it down to just nothing, and
Right.
not nil, an empty set in particular. If we get one error back, then we'll make a set out of that error, return that. If we get multiple errors, as we defined here, then we'll get the set from that errors. And this is what I was saying. I don't like the syntax of it. I'd like to just return errors, but this is as good as I can get it. Please help me. And then finally, because I can't say what type of error might be thrown, up here in the raw value definition, this is not considered to be exhaustive unless I put in a final catch, and so it will never happen. If it did, we would fatal error. So after we get that array of errors, we'll make sure that it's empty, and if it's not, then we will throw an error, this error type, and we will initialize it with our array of errors, which will then turn into a set, which we can find what we need from. Now I'll update the test function to handle multiple errors. The new important case is in the case where we get validate errors, we'll make sure that its set is equal to a set that's made out of the array that we get from this variadic parameter of errors. And we also have to make sure that when we do get one error back, that we actually expected one error with the precondition. We do that. And then we'll just make sure that the error that we got back is equal to the first of our expected errors. This will be the only error that we expected. Now we can create the test empty function in email test case that will return both the empty error and the format error that we expect when we pass in an empty string for validating an email address. This does not exist yet.
Poof!
When we go to the next commit, it does exist. I'll create effectively a new validate that is made of validate not empty and validate email address format. And I'll use lower camel case here because this should be a case. It is in fact a static function because this is a curried function, which is different than the upper Pascal case we have here. Is that clear to you or not?
Yes.
Okay.
No, I get you there.
Okay.
Mm-hmm. Because to me, the Pascal case means a type.
Okay.
So it's good enough for me.
Right. I'm considering everything that would be in there to either be an option or a subtype of that. We'll also add a test for valid emails. So when we validate this thing that is considered to be a valid email address, if an error is thrown, then we'll fail. The test will fail. But everything's good. So now, to the client, this composite function doesn't look any more complex than any simple static function would look. The only difference between this and how it might look in the future when it gets to be what I would like is that it's actually shorter, because at that point you'd probably be using .raw value here. So let's move on to a similar function where we validate password length. Scott used another validator for that. Just make sure that the password length is long enough. So again, we'll define the local error type is that of validate password error. And then we'll test length, validate password length, just as we had validate email address format. This password is not long enough, so we'll expect to get a length error. So I'll create a new group and a new file within that, similar to what we did with the email address section and the static function within. I'll create a section of validate that's just for passwords. We'll have a validate password length function within that. Make sure that it's long enough, otherwise we'll throw a length error. And again, we'll have to alias to an actual validate error. So now we have 3 cases, and I think you can see why I am using that particular method, because I would really like to say that password errors and email address errors are validate errors, but there's no way to express that I know of in Swift. Because right now, I can make a set of validate errors. But how would I make a set of validate errors if all the cases were not in this enumeration?
I don't know.
Maybe somebody knows. I think instead, though, that those who know anything will know that it's not possible. I hope that I am completely wrong and that somebody will tell me that I am wrong, satisfying Cunningham's law. Validating password strength is more complex to a degree. Scott made some extensions on string, which he'll use to validate password strength. He'll have 4 different types of errors that can be thrown. And then based on which one of those extensions is not satisfied, he'll throw a corresponding error. So I'll just keep those extensions directly, didn't change those at all. We'll make yet another section within validate password, this time for strength in particular. We didn't need it for length because there was only a validate length function, not a whole section of stuff that had to do with length. So we're doubly nesting now. And within password strength will have its own particular type of error. Each one of these 4 errors, again, is an alias to the real validate errors.
Hey, I like what you're doing with the case formatting here, since you can't use extensions to, add cases. You're sort of using case as a heading for new sections.
I guess
of errors.
I'm sort of emulating where I'd like to have in another file, say extension error, and then within that extension make more cases. I don't know why you can't do that.
Me neither, but this isn't terrible.
Now we have the actual function for validating password strength. Again, it uses camel case because it's a static function and not a section of validate password. I'm about to say another weird word because people say tuple and other people say tuple. In music school, we had tuples. In mathematics, it seems more common to say tuple. So I'm going to pretend that U is the U from put, because it's right in the middle of the two. So tuples it is.
Tuple?
Tuple. All right, so we have tuples, and we have an array of tuples that I'm calling validations. Each one will have what needs to be valid for the corresponding error not to be thrown. So all 4 of those errors that we defined are found within here. So for each one of these validations...
I see reduce here. Let me see if I have a handle on reduce. Ready?
I am.
Okay, so you're starting with an empty array of errors.
Mm-hmm.
Then you're iterating through the tuples in validations.
Right.
Guarding for the truthiness of each condition.
Yeah.
Otherwise, you're adding the error to the array,
mm-hmm.
and then it's returning an array of the accumulated errors.
Right.
Win.
Okay, and then after we have that accumulation, if it's not empty, then we're going to throw a validate errors made of that array of errors. We'll note in Validator configurator that Scott made that we'll need to validate that the string is not empty, that it has the length necessary for a password, and that it's strong enough to be considered a password. We'll make, effectively, a validate that is made of the validate not empty function, the validate password length function, and the validate password strength function. None of which requires an instance. Again, these are all just static functions.
Is it time to hit Command U?
It is time for Command U. So we'll validate that for an empty string, when we validate it as a password, that all the possible errors show up. It is empty, it's not long enough, there is no lowercase letter, number, no special character, and no uppercase letter either. When we have too short of a password, it's not long enough, there's no number, there's no special character. The only thing wrong with this one is that there's no special character. Again, you see how this is, because it's variadic, we can just expect a single error, whereas in all the other cases here we were expecting multiple.
That's pretty cool.
And when we actually validate a valid password, the test does not fail because the catch block does not run. Scott's playground and presentation were on the composite pattern. Is this still the composite pattern? I feel like I'm compositing things. I feel like I'm compositing functions, and I feel like I'm compositing errors. I don't know if it still counts because I'm not compositing types that implement protocols.
I don't know if it counts either, but it looks like a composition to me of things. The things are just functions.
And errors.
And errors.
Thank you.
Thank you for your time and attention.
Thank you for not smoking.
Thanks for spaying and neutering your...
Okay, that's enough.